So the industrial partner which we have here is of course the large-scale application of concrete in infrastructure, but also in the oil and gas field, so cementing in the oil well, which is a huge business and of high importance, specifically in the context of gas shale exploration. A tight cement liner in these wellbore applications of concrete is extremely important to ensure that no gas which is recovered at some kilometer depth will come into aquifers or to the surface, thus causing global warming potential. So these products which we develop from this type of collaboration actually immediately impacts the quality of the materials which are going to be used either in these niche applications like the oil gas, well, for the benefit of our society, making use of the gas shale revolution which is taking place in our country, or in mass application using less concrete to do more. So specific fields of application here could be city furnitures. City furnitures right now are done either in metal, aluminium, materials, but with those materials which are strong as steel but can be molded cold on site, it will be possible to create beautiful architectural structures for our cities. And that brings me to my other research field, which is urban physics. By urban physics, we understand the need to address the complexities of cities. The complexity of cities with regard to the energy consumption, but even more important, to make them more sustainable and more resilient as we face the threats of climate change. So what we have done in that field of urban physics is we have taken cities, looked at GIS maps and coordinates of buildings, and reduced them to individual points. And once you start these analysis, you realize actually that there is a strong analogy between cities on one side and molecular structures on the other side. Now, recognizing this analogy actually allows us to incorporate the whole field of molecular science into city science and addressing problems of urban physics. So for instance, we found out that Boston is very much akin in the layout of its buildings like a liquid, New York like a glass, and Chicago like a crystal. Now what do you do with this information? This information actually allows us to reduce the complexity of a city to a few parameters which we can then use to simulate the physical response of a city to storms, earthquakes, and so on. So here, as much as our activity on concrete, starting at the molecular scale, we use the same type of methods, physics-based methods, science-based method, in order to address urgent societal problems. How do we deal with our cities in the context of global warming?